Okay, this week's one lesson is on angles of elevation and depression, and it's very much an extension of what we've already been doing with the trigonometric ratios. Okay, the first thing that I want to point out before I read this is that what we're always doing is we're talking about a set of parallel lines. You're going to see some parallel line that is like if you're this hang glider, their horizontal view, right? Their point of view if they're looking straight out. This person on the ground or the horizon or the land is going to be this line. This is parallel with this. So then what you get here is you get this transversal cutting through here. So when you're looking down here, this is an angle of depression. You're saying how many degrees? And that's the same as if you were standing down here at this other vertex, the other end of this where the transversal crosses the horizontal lines, and looking up the angle of elevation, you would have that same angle because they are alternate interior angles. These are the parallel lines. This is the transversal. These are alternate interior angles. Okay, so let's read this now that we know that. It says, suppose a person on the ground sees a hang glider at a 38 degree angle above the horizontal line. This is the angle of elevation. Okay, at the same time, a person in the hang glider sees the person on the ground at a 38 degree angle below the horizon. This is an angle of depression. Notice that they're the same. Notice that the angle of elevation is congruent to the angle of depression because they are alternate interior angles. Got it? You can use the angles of elevation and depression as the acute angles of right triangles formed by a horizontal distance and a vertical height, meaning you could say this vertical height right here would make the triangle, right? You would have this side, this is the perfectly horizontal, this is the perfectly vertical. Here you have a 90 degree angle right there. Okay, and then this transversal line becomes the hypotenuse. Okay, and so if you knew this angle of depression was here, you could then translate that measurement right down to here. You'll see that work in just a minute. That's the basis of this whole thing, but we'll see it in action, and this should be a real, hopefully, straightforward lesson. Okay, we've got an easy start to this. What is the description of the angle as it relates to the situation below? Is it an angle of elevation or an angle of depression? If you're at angle 1 right here, which is what A says, you're at angle 1. Well, you're this bird and you're perfect horizontal. If you were to look down here towards the person in the hot air balloon, that would be an angle of depression. Okay, you can see what they say here. Angle 1 is the angle of depression from the bird right here to the person in the hot air balloon. Okay, what about 4? Well, if you're here at the base of the mountain and you were looking up to the person in the hot air balloon, you would have to look up. That's an angle of elevation. Elevations go up. Okay, angle 4 is the angle of elevation from the base of the mountain to the person in the balloon. So from the perspective, from the perspective of whatever vertex you're at, whoever's at that vertex or whatever's there, whether you would look down from horizontal or up from horizontal is going to be the difference. Down is going to be depression. I'm feeling down, right? That's the idea of depression, feeling down. Depressions are things that drop. Or an elevation, if you elevate something, you raise it up. Okay, so that you raise up your line of sight upward to look there at that thing. So that's an elevation. Okay, so what's the got it problem? What about 2 and 3? Pause it right now. Just take a quick stab at it and come right back. Okay, so angle 2 from the perspective of the person in the hot air balloon. For angle 2 right here, you would have to look up to the bird, and that would be called an angle of elevation. Angle of elevation. Okay, sorry for the sloppiness. And for 3, same person. Now they're looking down. Looking down means a depression, down towards the base of the mountain. Okay, so that would be an angle. I think I need a new tip on my pen. Of depression. That's it. That's how you do this. That's just the first part of it, of course, but it's important to just know it and identify it. Let's keep going. Okay, so here's a real life problem. You're using the angle of elevation. So suppose you stand 53 feet, this right here, your distance from a wind farm turbine. Your angle of elevation to the hub is where the turbine spins from, is the angle is 56.5 degrees, and your eye level is 5.5 feet above the ground. That's worth filling in here. Okay, this distance right here to the actual ground is 5.5 feet, and that's going to become relevant in a minute. But right now, because your eye level is up here, you just have from that level up to the hub is X feet, and we're going to calculate that. So what do we have for this measure? We'll check it out. You are talking about this angle, so you have the side adjacent to it and the side opposite. Okay, so opposite and adjacent uses the tangent ratio, and so you say the tangent of that angle, 56 degrees, 56.5 degrees, equals the opposite side, x, over the adjacent side, 53. So they've written it out like that. Okay, we're going to then rewrite that. Okay, you say multiply both sides by 53 to isolate x, and then you're multiplying the tangent of 56.5 degrees, which is in your calculator, times 53. So you hit 53, and then you hit the tangent of 56 and enter. It depends on your calculator. You might have to do it slightly differently. And you get approximately 80. It says, well, it doesn't say to the nearest foot, but let's round it off like that, okay? So that's how high this is right here, approximately 80 feet. Sorry, a little messy. Approximately 80 feet. But, however, your eyes are already 5.5 feet above the ground, so you're going to have to add that amount on. So this is what it says, okay? So x is approximately equal to 80, which is the height from your eye level to the hub of the turbine. Okay, to find the total height of the turbine, you add the height from the ground to your eyes. Since you are 5.5 feet above the ground, you take that 80, you add 5.5 onto it, and you get 85.5. So the wind turbine is about 85.5 feet tall from the ground to its hub. And this is where, there's no one easy, straightforward, perfect formula every time. In this situation, you've got to assess, oh, right, I'm looking for from the ground here, but this triangle, this angle right here doesn't start at the ground. It starts at my eyes, so we have to add that on. Okay, those are little details that mean that you need to extrapolate your understanding. You need to get the idea of how this works, and then you need to apply it correctly to new situations. And kids that rigidly get stuck in, I did a problem, I can only do problems like that, instead of saying, I get how you do this. I'm gonna apply this to new situations and see what new kind of things I need to take into account there are in order to get it right. If you extend yourself like that, you're going to do well with math. If not, you're just going to memorize a set of rules, not maybe always know when to apply them, but certainly not know how to modify them to fit a situation. So it's to your advantage to try problems like this and really stretch your thinking and work out all of the little particulars. Okay, so let's keep going and see how the rest of this applies. All right, so you got a problem for this one is, and of course, after we read it, you're going to pause the video before you see the solution. You're going to try this yourself first, okay? You sight a rock climber on a cliff at a 32-degree angle of elevation right here, okay? Your eye level is 6 feet above the ground. This is your eye level, 6 feet above the ground. And you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? Okay, pause the video here, calculate this all out, keep in mind all of the different variables that we had, like you're 6 feet above the ground, etc., and solve this problem, and then unpause it when your solution is there to check it. Okay, pause it now. Okay, so what we want to do is we want to label this side, let's just call this side X, right here. and see how high from eye level to the climber it is. So what are we dealing with? Well, we've got this angle right here, 32 degrees. We've got the adjacent side and the opposite side. That's going to be tangent. So we can say the tangent of 32 degrees equals the opposite side, x, over the adjacent side, 1,000. Okay, multiplying both sides by 1,000, you get 1,000 times the side, 1,000 times the tangent of 32 degrees, which again is just a value that's in your calculator that is the same always. Okay, so I'm going to take my calculator here, figure this out. Let's see, tangent of 32 times 1,000, and that is approximately equal to, x is approximately equal to, we've got 624.869. Okay, and let's just say we're going to do it to the nearest foot. So if we round this off to the nearest foot, we've got approximately equal to 625 feet. Okay, now the trick is your eye level is 6 feet above the ground, so we need to take that measure, and because remember, x isn't the total height of the climber, that's just the climber from your eye level up to them. You're already 6 feet above it. So you take 625 plus that extra 6 feet, and you get 631 feet. So, and we can I'll just type this out. So the climber is 631 feet above the ground. Yep, that's your answer. Okay, this problem has some cool math in it. To approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent right here, starting from a height at 2,714 feet above sea level. Now, this doesn't mean 2,714 feet above the airport, because the airport is 1,007 feet above sea level. So the difference between those is how high this plane is. Okay, to the nearest tenth of a mile, and notice we're starting in feet, we're going to have to convert to miles. How far from the runway is the airplane at the start of this approach? What is this length right here? Okay, that's what they want to know. So let's take a look at the solution here. First of all, the airplane is that 2,714 feet above sea level, minus the 1,007 feet that the airport is above sea level, or that far above the level of the airport. Okay, I'm going to write that amount in. Let's just draw this line right here. Okay, and let's just say that that is 1,707 feet. Yep. Okay. Now what's next? They say that this angle of elevation from the airport up to the plane is 3. If this is 3, why is this 3? The path of the airplane before the descent is parallel to the ground. This is parallel to the ground. These are parallel lines cut by a transversal. Okay, and when you have parallel lines cut by a transversal, these alternate interior angles are congruent. So the angles formed by the path of descent are congruent alternate interior angles. If this is 3 degrees, this is also 3 degrees. So I'm going to fill that in as well. 3 degrees. Okay. There you go. Sorry, taking a second. So what else do we know? Okay, well, what we want to know is this distance here along the hypotenuse. So compared to this angle, what do we have? We have compared to this angle, we have the opposite side, and we're looking for the hypotenuse. Opposite and hypotenuse. Opposite and hypotenuse. Opposite and hypotenuse. Sine. So, sine of 3 degrees is 1,707, the opposite side over x, the hypotenuse. And when you solve for x, what you see happen is these two values switch places. Okay? You multiply both sides by x, and then you divide both sides by sine of 3 degrees. This is when we were working proportions earlier in the year. You saw that kind of quick trick method. Okay, so now we've got x, that distance being 1,707 divided by the sine of 3 degrees. So you do that, you get this amount, and you say, oh, okay, so that says that distance, what they're talking about is that distance in feet. It is 32,616 feet. But they're asking for us in miles to the nearest tenth of a mile. So this is what it says here. You need to convert that to miles. You need to divide by 5,280, the number of feet in a mile, to split this into how many equal groups of 5,280 feet are there, or how many miles are there. So when you do that, you get 6.177, and they're rounding to the nearest tenth. It says up here at the top, to the nearest tenth of a mile. So what do you do to the nearest tenth? Well, this 1 is in the tenths place. Is this 7, 5 or higher? Yeah, it is. So that 1 should go up to a 2. The airplane is about 6.2 miles from the runway. That's a good problem, and it's worth watching a second time if you didn't get it. Okay, let's do got it problem for this. Okay, so here's your got it problem. It's the last problem on this lesson. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance, d, from the raft? Sketch it out. It's really going to be helpful if you make that drawing. And yeah, pause this video now, attempt that, and then unpause it, and I'll show you the solution. Okay, so here we are. I've made a sketch of this, and let's just see that we've got it all right. Okay, an airplane pilot spots a life raft at a 26-degree angle of depression. That's this right here, right? From horizontal, looking down 26 degrees to see the life raft. That means that since these are parallel lines, this is the surface of the water, that if this is 26, this is 26 as well. So now we've got this triangle, right? And the airplane's altitude is 3 kilometers. What is the plane's horizontal distance? Now, they're not talking about the direct distance like this. They're just talking about from level right here, how far would the airplane need to go forward in order to be directly above it or whatnot. Okay, so that's this right here. So we're looking for x right here. We've got this. Compared to this angle right here, what do we have? We have the opposite side, and we're trying to find the adjacent side. Opposite and adjacent. Opposite and adjacent. Opposite and adjacent. So we're going to be using tangent. Okay? So we then say the tangent of 26 degrees equals the opposite side, 3, and that's in kilometers, over the adjacent side, x. Okay? And remember what we said for isolating x. Our trick is if x is on the bottom, we'll end up switching these two. You multiply both sides by x, so it says x times tangent of 26 equals 3, and then divide both sides by tangent of 26. These will switch. Okay? So then what you get is x is equal to 3 divided by the tangent of 26 degrees. And we take my calculator and say 3 divided by tangent of 26. And I get 6.15 approximately. X is approximately equal to 6.15, and what is that? Kilometers, right? So that's an approximate answer. 6.15 doesn't say where to round it off. If it did, we could maybe say approximately 6.2 kilometers. Whatever. That is your answer. Good luck with this. I hope this makes a lot of sense. It's pretty straightforward and easy because I know that you want to study for the Q3 retest as well. So anyway, good luck with this. Do the IXLs. Nope, I think there's no IXLs for this one actually. Do the book problems, ask me any questions, and yeah, get yourself ready for that retest. Good luck.